There are a lot of videos out there about authentication and the OAuth 2.0 standard. I've even made a few myself. But in this video, I want to take a different approach. Instead of diving straight into specs and diagrams, let's talk about authentication through real-world use cases. Because in larger applications, authentication is not just about users logging in, it's also about securely interfacing with other services. And that's where OAuth 2.0 comes into play. Let's use a photo printing app as our example. A user can log in, select photos, and add them to cart and check out. But here's the thing. Besides uploading their own photos, many users will want to import images from services like Google Photos. And to do that securely, we need OAuth 2.0. So what happens when a user wants to connect to Google Photos? The user clicks Import from Google Photos and they are redirected to Google. If they're logged in, they authenticate with Google. Google shows a consent screen saying that the photo printing app wants to access their photos. The user agrees and gets redirected back to our app. Now they can see their Google Photos inside our application. That's the OAuth 2.0 authorization code flow in action. But how does it look from a developer perspective? As a developer, here is what you do. You go to the Google Cloud Console and create a project with access to the Google Photos API. You create an application, define the scopes, read-only in our case, and set a callback URL. This is where Google will send the users back after they authorize. Google gives you a client ID and client secret, which you must store safely as environment variables and never hard code. When the user wants to access their Google Photos, you redirect them to Google's OAuth URL, passing the client ID, scopes, callback URL, and specifying the code grant type. After the user approves, Google sends a temporary code to your callback URL. On the backend, you exchange that code for an access token and a refresh token using a POST request along with your client ID and secret. You store those tokens securely, linking them to the user in your database. The access token is what you use to call the Google Photos API. It's usually valid for a few hours. When it expires, you use the refresh token to get a new one. Refresh tokens can last for years. The beauty is that once the user connects to Google Photos, they don't have to go through the flow every time they log in into your app. OAuth 2.0 is a standard and it works the same way whether you're connecting to Google Photos, Amazon Photos, or any other service. Most providers even give you SDKs to handle the heavy lifting of the flow. An important point, an OAuth access token is usually a JWT, a JSON Web Token. It has information such as user ID and permissions to authorize a request to a resource, but you can't use it for authentication. Currently, to authenticate a user into our photo printing app, we might store usernames and passwords in a database. But modern apps have much higher expectations. Users expect social logins like Google or Facebook, multi-factor authentication, and single sign-on for enterprise. On top of that, you have to handle user data securely, sometimes with compliance requirements like HIPAA for healthcare or PCI for e-commerce. This is where services like Auth 0 or Amazon Cognito can save you a ton of work. Let's say we pick Cognito. It uses the same OAuth 2.0 flows but adds OpenID Connect or OIDC. That means when a user logs in, we can get ID token containing their profile information for authentication. To set this up, you create a user pool in Cognito, which is essentially a user directory. You decide whether a user log in with a username, email, phone, or a combination. Then you create an app client connected to the user pool, define scopes like OpenID, profile, and email, and set a callback URL. Finally, you configure a domain for the OAuth 2.0 flow. Cognito provides a hosted UI that handles login, sign-up, password resets, multi-factor authentication, and social logins right out of the box. You can customize it to match your branding, so users barely notice they've left your site. When the user clicks Sign In, you redirect them to the hosted UI. They enter their username and password, and Cognito redirects back to your app with a code. You exchange that code for tokens, an ID token, an access token, and a refresh token. Typically, I decode ID token, create a session for the user, drop a secure cookie, and handle authentication via sessions. Normally, I discard access and refresh tokens. However, if I'm building an API-first application, I will use access and refresh tokens to communicate to the API. In that case, I may add them to the user's session, and then use refresh token to get a new access token if it expires before the session ends. So far, all these flows involve a user. But what if our app needs to talk to another service without user involvement? Imagine our photo printing app integrates with an e-commerce backend like Commerce Tools or for products, carts, and checkout. The connection isn't tied to any user. It's tied to us, the merchant. This is where the OAuth 2.0 client credentials flow comes in, also known as machine-to-machine token. In this flow, you create an application in Commerce Tools, assign permissions, and get a client ID and secret. Your backend stores those securely and uses them to request an access token. That token is then used to add products to the cart, create orders, and so on. Then, when the token expires, usually after 24 hours, you request a new one. Most SDKs handle this automatically once you configure them with client credentials. One thing to keep in mind is that authentication URL you use to get access token may be different from the actual API URL, and it is often rate limited, so you don't want to request the access token on every call. To recap, access tokens let you access resources. Refresh tokens get you new access tokens when they expire. ID tokens are used to get user information for authentication via OpenID Connect. And machine-to-machine tokens let your app talk to other services without user involvement. OAuth 2.0 is the backbone of modern authentication and authorization, and understanding these flows will make building secure application so much easier. If you want to learn more about JWTs and what makes them secure, check out this video where I break down how they work under the hood and how to validate them properly.